Okay, let's continue. The previous video started the exercises 1.1 of Mr. John Coburn's Precalculus textbook. We'll be continuing it. We ended at number 101. Let's start with 102. So, the speed of a current. An instrument called a flow meter is used to measure the speed of flowing water. Alright, let's just skip what we have there in the given. I'll be pretty straightforward. Wheel has a radius of 5.6 feet, and the wheel is turning at it is turning at 30 rpm, or revolutions per minute. So what's the angular velocity in radians? So W is equivalent to theta over t. W is equal to theta, 30 revolution over minute, so 1 minute per minute. So 30, one revolution is 2 pi, in other words, and 60 pi rad over 1 minute. This is the angular velocity. Okay, let's move on to letter B. Linear velocity in miles per hour. Sorry. V is equal to RW. V is equal to radius, which is 5.6 feet, over 1 rad, times W, which is 60 pi rad over 1 minute. Right, I don't think we have much space. Let's bring this down here. Okay. Need more space. So we convert from feet per minute to miles per hour. So 1 feet, 1 mile is how many feet? 5,280 feet. I hope I'm not wrong. I'm pretty sure this is the equivalent number of feet in miles, in 1 mile. For minute, 60 minute is 1 hour. So let's start canceling. Minute, feet, rad. And what we get right now is V is equal to 11.995 miles per hour, or approximately 12 miles per hour. Okay, 103. Change of elevation from A to B. These two problems, actually, for numbers 103 and 104, this is something that you wouldn't find any reference from in the previous video, not the part 1, the lesson video. This is all about special triangles. So yeah, I'm going to explain how we're supposed to solve this in a more detailed manner. So first, we have to write what the contour interval is. We have to list what it is. So right now, the contour interval is 1:250, as stated here. So each figure indicates a change of 250 meters in elevation. So the figure in this graph, in this illustration, that would be the lines. So this line is not counted as a figure. What's counted as a figure are these ones, 2, 3, 4. So basically we have 4 figures for 100 number 103, and um, the scale of the distances is 1 centimeter is equal to 625 meters. This will come in handy later. So we have to find the change of elevation from A to B for letter A. Uh, how are we supposed to do it? We use proportion. So we know that the contour interval, in the contour interval, 1 is to 250. What about 4? This is the missing value. If 1 is to 250, 4 is to what value? This is a change in elevation from A to B. Why do I say 4? Since we have 4 figures. And one figure is 250. So basically, or literally, 4 times 250 is 1000. This is the change in elevation between A and B. That's how far they are from each other by elevation. Okay, so for letter B, use proportion to find the horizontal distance between A and B if the measured distance of the map is 1.6 centimeters. So this is basically conversion factor. We apply the techniques of conversion factoring. So in this sense, we have 1 centimeter, 625 meter. Why did I label it this way? As I said earlier, this one will come in handy. I think this is where we use it now. And why did I label it as the way they are written here? To eliminate centimeter. So 1.6 times 625 is 1000 meters. This is the final answer for letter B. And now, for letter C, we're supposed to draw the corresponding right triangle. Use a special triangle relationship to find the length of the trail, up the mountain side that connects A and B. So, right now, this is a right triangle, and this will always be 90 degrees. Based on what I'm seeing right now, it's already quite obvious. You can already make assumptions on what kind of right triangle this is. Actually, we do have 2 triangles. One is 45, 45, 90, and the other is 30, 60, 90. 45, 45, 90 is basically an equilateral triangle, if I'm not wrong. But at least 2 sides are... No, it's not an equilateral triangle. It's rather isosceles in a certain sense that 2 sides are equal to each other. And one is the hypotenuse, which has a rather higher or a longer length. For their 30, 60, 90 degrees, it's basically the opposite of equilateral and isosceles. One side is 60, one side is 30, the other is the hypotenuse. So yeah, that's just a brief overview of what the 2 special right triangles are. In this case, I'm starting to think that since we have 1000 for A and B, this might be a 45, 45, 90, wherein one side is 1000, the other side is another 1000, and degrees are 45. Okay, with that in mind, it's always that for 45, 45, 90 degrees triangles, we have specific, so we write it this way, this way literally, and hypotenuse will always be square root of 2 and times a, or just a times square root of 2. Now, what we're trying to find, what we're being tasked to find is the length of the trail up the mountainside that connects A and B. So that technically is the hypotenuse that we're trying to find. So with this in mind, let's apply that. A times the square root of 2. So please bring your calculators out. It's going to be very important. So the answer is 1414.213562, which is, yeah, you get something like this as your answer. I hope it makes sense. I'm pretty sure that it won't exactly make complete sense, but then, yeah, I hope you'll get used to how these problems are solved, the approaches. We just gotta make use of what we have available, and yeah, try not to veer away from logical assumptions, since they might be useful, especially when a problem has unpredictable solutions. Okay, for number 104, special triangles. 2 by 4 handrail, leading, they must be replaced. The handrails must be replaced. Contour interval, you have to list that one. Contour interval is 1:200. Each figure indicates a change of 200 meters in elevation. So yeah, that's a basic definition of the ratio. And the scale of the distances is 1 centimeter is equal to 400 meter. Alright, first we have to find the elevation from A to B. Elevation from A to B. Our solution for that is, since contour interval states that 1:200, and how many figures do we have in the illustration? 1, 2, 3, 4, and 5. Of course, we don't include the outermost line. As I said earlier, we only include the lines within. So we have 5 figures. So 1:200 and 5:, what? 5 times 200 is 1000. So this is the final answer. As coincidental as it might seem, for letter A in 103 and letter A in 104, they're not coincidentally the same. It's just intentional that the ratio values, inputs cause the outputs to be the same. But yeah, I think you do get the point. 200 times 5 is 1000. 250 times 4 is still 1000. You couldn't really change that unless you do change the inputs to make that product. Anyways, you shouldn't really think that much about that. So letter B, use a proportion to find horizontal distance between A and B if the measured distance on the map is 4.33 centimeter. Okay, so we're given a clue, 4.33 centimeter. We convert that to meters, I suppose, based on this one. For some reason, I couldn't really say why, the reason why, but yeah, that's what we have, and we'll make use of it. 1 centimeter, 400 meter. Cancel the centimeter unit. 4.33 over 1 times 400 over 1. We get 1732 meters. This is the final answer. That's the horizontal distance. Okay, we have to use a special triangle relationship to find the length needed, to replace the handrail. So this might be useful. So from this clue, square root of 3, it's pretty apparent that, wait, let me just show you something. So from what I've told you earlier, 45, 45, 90 triangles. 90 degrees here, 45 degrees there, 45 degrees here, and these sides are equal, and the hypotenuse is 2 8 times the square root of 2. This is everything that you have to know for the 45, 45, 90 triangle. For the 30, 60, 90 triangle, or 60, 30, 90, whatever you call it, anything would do, I suppose. 90 degrees, 30 degrees, 60 degrees. The values here are different, as well as this one, such that here, I'm so sorry. Wait. I also got confused with what I actually said. I need some time to think. Okay, I think I'm understanding where I'm going. So we have A here, and the hypotenuse will always be 2A. This is exclusive for the 30, 60, 90 triangle, so please pay attention more than usual. Here we have square root of 3 times A, or A times square root of 3. So with this, recall that square root of 3 is 1.732. It already suggests that our triangle is the 30, 60, 90, solely based on the square root of 3 here. We have square root of 3 here in one of the sides of the 30, 60, 90 triangle. Hence, let's just draw it. Space is too small. Anyways, let's just find the space here. So suppose this is 1000. This one is 1732 meters. And here we have a missing value for the hypotenuse. How can I prove that this is 732 meters? 1732 here in this side. Well, based on the default formula, so 1000 times the square root of 3, that is 1732. It proves, it shows true to its identity. Of course, this is already rounded off as a whole number. No more decimal points. So use a special triangle to find the length that needed to replace the handrail. So the hypotenuse here is the handrail that needs to be replaced. So this is basic trigonometric Pythagorean theorem formula. Hypotenuse is equal to I think this is it's like this. So 1000 raised to 2 plus 1732 raised to 2. 1000 raised to 2 plus 1732 raised to 2 is 399,000. I'm so sorry. This is 3,999,824. which is technically, if you put a square root on both sides, it's about approximately 2,000 meters. This is true. You can say that this is true since based here, the hypotenuse is 2a and this is a, wherein if the hypotenuse here is 2,000, technically this is a, right? And 2 times a is 2,000. These are the same. So yeah, I hope you could see that magic. Well, it's not exactly theoretically considered magic, but it's pretty logical and mathematically proper. Right, let's move on to 105. Two light planes are flying in formation at 100 miles per hour. Doing some reconnaissance work, designed at a designated instant, one pilot brakes to the left at an angle of 90 degrees. So obviously, we make a triangle wherein, so this is the 90 degrees. This is plane 1. The other is plane 2. So they keep the same altitude and continue to fly at 100 miles per hour. We're supposed to, hang on. Right, we apply 100 miles per hour on both sides according to the instructions to the given. Use special triangle to find distance between them after 0.5 hours. So 100 miles is to 1 hour. How many miles is to 0.5 hours? So that's a question now. Technically, 0.5, so 1 divided by 0.5 is 0.5. 1,000 divided by 2, the half of it is 50 miles. So you could say that the distance between the two, since both fly at the same miles per hour quantity, 100, each has been 50 miles apart after 0.5 hours. So you could say that the triangle is a 45, 45, 90, since sides A and B, in the context of Pythagorean theorem triangle, they're equal, while the hypotenuse has a different quantity. And that's the missing value. Find the distance between them after 0.5 hours. They've flown 50 miles away from each other, but this hypotenuse is the actual measurement of their distance. So yeah, how do we find letter C, or the hypotenuse, which symbolizes the distance between the two planes after 0.5 hours? Basic Pythagorean theorem formula. We do something like this. So 50 raised to 2 plus 50 raised to 2, C raised to 2. Let's see. Calculator says that it's 5,000. So square root on both sides. We get 50 times the square root of 2, or 70.71 miles. Okay, I think this is the final answer. So yeah. it's more likely that your answer is supposed to be in decimal form, so be it. For 106, I think this is the last question involving the application of special triangles. So two ships are cruising together on the open ocean at 10 nautical miles per hour. Oh my goodness, nautical miles. They are different with miles, but in the context of uh, this lesson, I don't think there's a difference between them. Nautical miles or miles, I think they're the same. Even though the scientific calculator or everything else proves it that nautical miles and miles are different. They're not equal. Anyways, in this question we just have to assume that NM is MI. NMI is MI. So one of them turns to make a 90-degree angle, so it's obviously a triangle. Again, with the first. By the way, the triangle I made earlier, it's not to scale. As you can see, this side is shorter than this, but yeah, I just want to let you know that. So 90 degrees here, with the person increases speed heading for port. First ship continues traveling at 10 knots. Wait. It's just, oops. 10 knots. Knots is equivalent to nautical miles. Anyways. Use a special triangle to find the speed of the other ship if they are 20 miles apart after 1 hour. So this is 20 miles apart after 1 hour. So right now, what we're looking for is letter B. And it's pretty likely that this triangle is a 30, 60, 90 triangle. Oops. Since this is A and this is 2A. This is what we generally have for the 30, 60, 90 triangle. And here, it's A times the square root of 3. Let's just write something like this. Okay. But right now, I think we have two ways to solve for letter B, or this one. This is my first way. Since we know that B is A times the square root of 3, such that A is 10. So 10 times the square root of 3, let's see, 10 times square root of 3 is 17.32050808. 17.32 miles. This is the distance that if you say nautical miles. And yeah, I think this is the final answer. Now let's try to use the second way. So given, we write something like this, wherein c raised to 2 is 20 raised to 2 minus 10 raised to 2. Let's see, 20 raised to 2 minus 10 raised to 2, 300, square root of 300. B is equal to 17.32. Literally the same as what we have here. Okay, that's it for 106. Mission solved. 107, I suppose this is my last question. Actually, there are a lot more questions, but yeah, it's basic. I'm basically not answering them anymore. Yeah, you might want to use this as reference. Yeah, we'll be ending the video with the finishing of 107. So, let's end it strong. Angular and linear velocity. Jupiter, so the radius, the distance is about 656,000 miles. In an orbit that's perfectly circular. The moon completes one rotation in Jupiter, so one rotation in 7.15 days. For letter A, find the degree that the moon moves through in one day. Okay, so we have one rotation per 7.15 days. One rotation is one revolution, which is 2 pi. So we get something like this for theta, I suppose. And hang on, let's put those values in the calculator. So 2 pi over 7.15, we get 0.88 radians, or if we want it in degrees, it's 0.88 over 1 times 180 over pi, which is 50.42 degrees. But wait, okay, I'm so sorry. I forgot to explain about ratio and proportion here. One day, what's being asked for theta is 1 day. This one is for every 7.15 days. But at least we made some progress. Indirect progress. So yeah, let's rewrite. Remove everything here. But we do know that in one day it's 0.14 rotations. We use our good old-fashioned ratio and proportion to determine that. So theta is equal to 0.14 times revolution over 1 day. So 0.14 times 2 pi over 1 day. 0.14 times 2 pi is 7 over 25 pi radians over 1 day, which is, in other words, 0.88, the same as earlier. Radians, this is also in radians. If we want to convert it in degrees, our answer is 50 0.42 degrees. Any of these answers are okay, I think, or acceptable. Okay, move to letter B. You have to find the angular velocity of the moon in radians per hour. Angular velocity is theta over time, wherein right now we have 0.88 rad. Let's just write that over 1 day. I think this is our actually no, this is not it, our answer. Yeah, it's not our answer yet. Let me try something else. So given that our one rotation is 7.15 days, let's use that as our basis for the angular velocity. So 1 times revolution over 7.15 days. So 1 day is 24 hours, while revolution, wait a minute, wait, I'm not supposed to cancel yet. I haven't even made simplifications yet. 1 times 2 pi over 7.15 days. 2 pi rad over 7.15 days. One, actually no, 1 day, 24 hours. Okay, put the values in the calculator. 2 pi over 7.15 times 1 over 24, we get 0.03661529899 or 0.04 rad per hour. I think this is the answer. Yeah, this is the answer. If you round it off to two significant figures or two decimal points on the right, the nearest hundreds. Yeah. Okay, we're almost done. Oh yes, we're almost done. Let's go. Letter C, the moon's linear velocity in miles per second. The linear velocity formula is this one, and our radius is 656,000 miles. Whatever the radius, it's always over 1 rad, 1 radian. And for the W, the angular velocity, it's 0.04 rad per hour. So from mph, we want it to mp miles per second. So I think we just have to change one thing here. We don't have to convert miles into something else. For both miles, we have to change the time though. So from hour, how many hours are there in one? How many seconds are there in 1 hour? 3,600 seconds. So remove that. Remove these two. Put the values in the calculator. So 656,000 miles over 1 rad times 0.04 radians over 1 hour times 1 over 3600 is V is equal to 7.29. 7.29. Hang on. I'm so tired. Actually, let's try to. This is actually the same answer, but then let's make this 0.036 rad per hour. Why is it 0.036? Well, it's also 0.04, but round it off to 3 significant units or to the nearest thousandths. So I think that's the problem. Right. Now we have the answer. Wow, what a big difference. A while ago it was 7, now it's 6. I don't know about that, but this is the answer according to the book. Yeah, we finished it. Whew. Damn, that's pretty taxing. Yeah, I'll leave the rest up to you. These are higher order thinking skills problems. So anyways, even so, I hope this video helped. This is part 2 of exercises 1.1, Precalculus of John Coburn. Thank you for watching.